Hello and welcome back to Business Analytics. My name is Hari Rajagopalan and I shall be your instructor for this session. So we are in predictive analytics. We've finished regression and we are looking at data mining. So we're going to kind of do a little bit of review today of data preparation, data visualization. And let's look at where we are here. Data mining looks at identifying opportunity, collecting data, explore, understand, and prepare the data. And this is what we're going to focus on this lecture is explore, understand, and prepare the data. And then we're going to identify tasks and tools, partition it, evaluate, build a model, deploy the model. So the getting the data we talked about is there's a get data in the worksheet, there's exploration, and then there's transformation. And we are really focusing on exploring and preparing the data and making sure it's okay. So let's start with data exploration. Before we even start fetching random samples, now you can do it on your sample if you have a really huge piece of data set. So let's say you have 400 million transactions you're looking at, you might want to first fetch the data before you do data exploration because it's going to take a long time. But if you have a smaller data set and you still want to do a sample, then you can start with exploration and then sample based on it. So the data set we're going to use is we have a product sales and then different sales price, ad spend. That is how many dollars you're spending on advertisement, what the budget is for that entire unit, the account executive who's in charge, product level, that is 1, 2, and 3, and then region, different continents. So sales price, ad spend, and budget are continuous variables. Account executive and region are nominal categorical variables, and product level is ordinal variables. So, and the dependent variable, of course, sales is also continuous. So we're going to look at the visualization. And visualization, you have bar charts, you have histograms, line charts. We'll talk about what a parallel coordinate is, scatter plot matrix, box plot. And then we're not going to get into Power BI or Tableau because it's beyond the scope of this particular program. So let's go to Excel. All right, so here is the data set, and while we can definitely take a sample of it, I'm going to explore this entire data set because we have only 300 data points and therefore this is not that large. So you can, if you go to your data and you go to filter, you can see here's your price point, you have ad spends in dollars, these are continuous, you have account executives, you have Adele, Fred, Haya, Hubert, John, Juan, Kenisha, and Mary. You have product levels 1, 2, 3, where this is ordinal. You have regions of Africa, Americas, Asia, Australasia, and Europe. Looks like each continent is one region. And then here you have this sales. And you can sort this data. You can reimagine it. You could probably use a pivot chart. But let's look at what Analytics Solver gives us. So the first one, before we get into Chart Wizard, I would like to look at this feature selection. And what this feature selection does is to tell us which of these have an impact on sales. So let's start from scratch. And so here we have when you first start, this is how you're going to see it. It's going to ask you for a data range. You can select all the data. Control Shift and down will take you to the last part. Click OK. That gives you 289 rows and 7 columns. If first rows contain headers, you check this on. Your continuous variables are ad spend and budget. Your output variable is sales and it's continuous. Now you can go next. You can look at options to discretize the predictors, which is essentially convert these into discrete values. So if you check this and click advanced, you can look at how many bins and whether you want equal interval or equal number of stuff. So whether the bins have to be equally spaced or do you just want equal number of items in each bin. Similarly, you can discretize the output variable also, and you can change the number of bins here. But if you choose to use continuous variables, you can look for correlation filters. Pearson's correlation, if your data is a rank or ordinal, you can use Spearman rank correlation. And then you have the Kendall concordance. You use the Kendall concordance when you are looking at raters, agreement between raters. So the Kendall's W ranges from 0 to no agreement to 1 to complete agreement. So for example, if you had a number of people asked to rank a list of political concerns from most important to least important, and then Kendall's W can be calculated from this data. But for this particular data set, Pearson's correlation would work fine. If you are looking for what these other data sets is, you can just click the help file, and this will actually take you to the help section here, and it actually talks about what these different tests are. So for example, Welch test is a 2-sample test which is applicable for binary classification problems. It used to check the hypothesis that two populations with possibly unequal variances have equal means. Again, you have the F test which you've done, you have a chi-squared test. If you have two discrete nominal variables, you can use Kramer's W. Here you have the Fisher score. So there is a bunch of different tests which you can use. Gini index measures the variable's ability to distinguish between the classes. The smaller the Gini index, more relevant the variable is. So you have a bunch of this, but for this part, we have continuous values. We are going to use Pearson's correlation. And then we can go next. And here are our outputs. We want the table of all produced measures, feature importance plot. So we can look at maybe top 2 features, and you can rank by Pearson's correlation, or you can get a p-value statistic. Basically, if you want to use the p-value significance statistic. So let's use the Pearson's correlation right now and click finish. You get the data range. This is the inputs. It shows what features you have selected here. And here we go. We are looking at, let's look at these percentage values. All 3 of them are statistically significant. Price is strongly negatively correlated with sales. It's 99.89%. Ad spend and budget, there's a little bit more spread. It's not as strongly correlated. And so you can kind of go, price is the biggest significant impact for sales, and then ad spend and budget affect it further. So here is the importance, price, and budget are the top 2. And then of course ad spend is next. And budget could be the entire budget for that particular division at that point of time. So these are the top 2 importance for this particular. So feature selection, and especially when you have 30, 40 variables, comes very, very useful. Now let's look at same feature selection, but for the categorical variables. So as you can see already, I've already selected the categorical variables: account, executive, product level, and region. And here is sales. You go next, you'll see that everything is grayed out. And the reason is because when you have this is expecting you to have categorical sales. So I'm going to discretize the output variables, make it categorical. I don't need 145 bins. Let's say we have 6 bins, and let's assume equal interval instead of equal count, spaced equally. And so then now we can do a chi-squared test if you want to do a Kramer V, which is very similar. We can look at mutual information, grain ratio. Let's generate this, and then let's use this to figure out what they mean. So let's go ahead first, go to next. I'm going to look at the top 2 importance plots and we're going to rank by chi-square statistic. So if you go here, here is all the data you have. So let's take a look. So we have account executive, product level, and region. Product level seems to be really significant effect, whereas region or account executive doesn't seem to have much. And if you look at the top two features, definitely the product level has a great level of impact, whereas account executive not so much. Let's talk about what these values are. So let's look at Kramer's, like here's the chi-square, here's Kramer's V. So let's look at Kramer's V is a variation of the chi-square statistic that also measures the association between two discrete nominal variables, but it's from 0 to 1. 0 indicates no association and 1 indicates complete association. So when you have a range of 0 to 1, you can compare it. Mutual information, and in this case we talk about mutual information, is 1.26 for product, whereas here is 0.08 and 0.001. So really small for region. What does this mean? Is the degree of the variable's mutual dependence, or the amount of uncertainty in variable 1, that can be reduced by incorporating the knowledge in variable 2. So as we can see, the more significant product level reduces the uncertainty for price. Product for sales, not price, and that has a high value for mutual information, whereas the other two are not very good and therefore have a low value. The gain ratio ranging from 0 to 1 again is for normalizing again the mutual information or information gain, and it also, the normalization addresses the problem of overestimating features with many values. So it's good practice to look at both, because this has some advantages, whereas gain ratio has other advantages. Now, normalization overestimates the level irrelevance of the features if it has low level of entropy or low error rate. So it's good practice to consider both information, both for mutual information. The larger the gain ratio, the larger the evidence for the feature to be relevant in this classification model. So that's what we have, and you can see both the mutual information and gain ratio is quite large for product level and quite small for region and for account executive. Okay, so with this we finish the issue of feature selection. As we explore data, let's look at the data visualization, the different charts which are available here. And so as you look here, we have, let's go down, scroll down all the way up to this. And so now you have bar charts, histograms, line charts, parallel coordinates, scatter plots, scatter plot matrix, which is multiple scatter plots, box plots, and here we have variable, which is all variables in a single display. And this is when you can use other data visualization software like Power BI or Tableau, which is beyond the scope of this this particular chart. But so let me walk through the interface here, and then I won't go over bar charts and histograms and line charts and box plots, but I'll talk about parallel coordinates and scatter plots. So first step, box plots, you can select your y-axis, which will be sales, and then you can look at your x-axis. In this case, it's automatically selecting the categorical ones. So let's do it by product level. Actually, let's do it by region, and we want each account executive to be different colors, and then each panel for each product level. And so there you go. You have your chart wizard, and you can kind of start modifying it. Now you don't have to stick with this. So you can go and say, hey, I really want to look at account executive and region, and this does that. Or you can say, I want it by product level and for each account executive. And you can kind of move things around here, but here's for region. So each region has a different panel. You can look at how these account executives have performed. So definitely pretty cool kind of a method here. I wanted to talk a little bit about, not that, I want to talk a little bit about your parallel coordinates. So when we look at these parallel coordinates, and parallel coordinates draw a line for each observation, connecting its value on the different axes, thereby creating a multivariable profile. So let's take a look. A line is drawn connecting the values of observations for each different value. And these graphs can be useful for prediction and possibly how you're going to bin your data. So these graphs can expose clusters, outliers, variable overlap. Axis can be reordered by simply dragging and moving the axis to a desired location. So let's look at some example of a parallel coordinate plot. Okay, so we are here, and what I'm going to do is ID is not, but I'm going to just go ahead and select everything and throw it out there so you get a plot here. And then I'm going to go ahead and remove some of the stuff which I don't think are very effective. So for example, account executive is not going to be very effective with sales. I'm going to remove that. I'm going to remove region from this. And so as you can see here, product level, there are four, with sales, there are about 4 clusters here. It's anywhere between 37.327 million to 37.626 million. That's your scale, and then your product level is kind of somewhere you can, and if you kind of want to look at by region, and you can see that you see a lot of purples and yellows, which is Americas and Asias. You don't see that many greens, Europes here, or blues are very small. So here you can see clear pattern between product level and sales. I don't see, seems to be price and ad spend. This seems to be more chaotic. So let's try something else. Let's go ahead and remove product level, and I am going to remove ad spend and budget, and let's see how price is affecting sales. You can look at this where you say, hey, here is this price, low prices are going to high prices are going to low sales. You can see that, and we can go ahead and let's look at from an account executive purpose or a product level. Oh, nothing there because it's only 1, 2, 3. Let's see, there we go. So let's look at the next stage where we are looking at price, and let's see if there is some comparison between product level, price, and sales. And you can see that again, you can see clear patterns here. Product level 1, and if we change, let go of the color, but if you want to look at regions, so it gives you some idea of what's happening here. It looks like product 1 is kind of at a higher price, and product 3 seems to be at lower prices, whereas product 2 is in the middle. Like I said, I randomly generated these numbers, so it doesn't make any sense, but at least we can see some patterns here. And so you can start looking at these patterns. So that's the data visualization for parallel coordinates. And here, when you do the variable, and it basically gives us a chart for all your variables. And you can look at, here is how my budget is distributed. Here is how product level is distributed, and it gives a kind of, we don't need ID. Sales, you can look at the budget, seems to be kind of normally distributed here. So it's kind of cool. Gives you a nice little graph there. So this is our data visualization component. I encourage you to go ahead and mess around with it and explore more of it. It will be helpful for you to see how the data is. So we did a bit of the data visualization. The next stage is actually getting data either by random sampling or stratified sampling. And so let's go over to Excel and see how we can go about doing this. So here we are going to look at, and we have options, but we're not going to look at big data. We're not going to actually select data from a file or database. We're just going to use the worksheet here. And we're going to essentially select all these variables. You have an option for sample with replacement. I'm going to get a sample size of 40 with simple random sampling or stratified sampling. And you can figure out where the stratification comes from. So for example, I can say account executive is the stratum. So there are 8 different account executives there. Or product level, there are 3 different product levels. Everything should have a representative, or by region. So depending on where you want it kind of come from, you've got to kind of do that. You can say proportional to stratum size, equal from each stratum, or equal from each stratum, the number of records equals to the smallest stratum size. So I'm going to just do a simple random sampling right now. And then you sample by replacement if you want the same thing to be selected again. Now we are not going to do that here. So if you click OK, this should generate your sample, random sample here. This is the set you're going to do the data analysis from. All right, so this finishes our fetching data and creating a sample. And we're going to the last part, which is data transformation. The last part of this is data preparation, is data transformation. You look at how you're going to handle missing data, if you need to transform continuous data into categories, categorical data into continuous part, if you want to group independent variables together in principal components. Now, this is going to be, I was going to merge all of this together, but I've decided to split the videos into 2 because it's already 20 minutes past, and so I thought we'd take a break, and then the next video we'll talk about data transformation.